The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning everyone. Welcome to the first IT Masters Cisco CCNA MOOC. So welcome all here today. This, as you can see from the first slide there, this was a MOOC that's based on our ITE 526 Practical Internetworking subject, which is part of our Masters programs. So my name is Matt Constable. I've been in the IT industry for 20 years. 14 of those years I've been involved in specifically networking with some overlap in security, wireless and voice. I've worked across a number of different sectors, so government, education, financial services, service provider and retail, and on both sides of the fence, so both in the customer side and the integration side. Qualification-wise, I have a computing degree and a Master's of Computer Security and various industry certs, which I've had at different times, covering most of those areas. So whenever I've dropped into a new area, I've decided to take the certification. Having said that, I certainly don't have all the answers. So I'm hoping that with the numbers that we've got enrolled in this course, there will be obviously a lot of experiences, a lot of knowledge out there. So, please don't hesitate to post things to the forum, send some emails in, put some questions up or chat to me during the webinars. Everyone's got something to offer, and if we encourage this interaction through the forum and through these webinar sessions, then I'm sure we'll all learn as much from each other as you do from the content here. Okay, so our webinar class times. So they will run on Wednesday mornings from 10 a.m. to 11:30 a.m. Now that's at the moment Australian Eastern Standard Time, so that's UTC plus 10 hours for those of you in other time zones. Week 3, we kick in with daylight saving, so that will then become UTC plus 11. It'll still be 10 a.m. our time, but UTC 11, so you'll need to adjust your times during week 3. We've had a couple of questions already about the actual webinars and when they'll be uploaded to the IT Masters Moodle site, so they'll be there within 24 hours. You'll have the option to see them under YouTube. I'll also put them up in MP4 or WMV format as well, which should help most people out, should cover most electronic devices. I'll also put up a PDF copy of the slides in a note format so that you are able, if you can't get to this lecture, you'll be able to sit down and listen to the lecture and make notes as you go along. I'll also be posting plenty of other resources throughout the course as applicable to the particular technology we're talking about. There'll be PDFs, there'll be links, there'll be all sorts of things. They're there to try and enhance your experience. So they're not maybe necessary, depending on your background knowledge, for you to be able to successfully negotiate the MOOC or to then pass the CCNA exam if that was what you wanted to do, but they will enhance your learning. Okay, contact details. You can get me at this email address anytime. I'll usually answer within 24 hours, sometimes a heck of a lot quicker. As far as the forums go, I'll be monitoring them pretty much every day, and I would encourage you to mainly contact me through the forums, particularly if you have any questions on the technical component of the session, mainly because it then shares your question and my answer with everyone at the same time, so everyone's able to look at it. If it's just that one-to-one email, it'll get lost in the translation. If a particularly good question does come in by email, though, I'll post it on the forum as well. If you've got any questions about our IT Masters courses, which I'll go through in a little bit of detail in a minute, please feel free to direct them to me direct those questions directly to me by email. If I can't answer it, I'll get one of the guys at IT Masters to answer it for you. Okay, if we have a look at what IT Masters currently offers in the Networking and Systems Administration course for next year, you can see that's a course structure that's going to be in practice for next year. You've got some core subjects which obviously cover a range of different technologies. So there's not only technology components but business components and professional communication components. The restricted academic electives, you can see those there. Now every single one of those I can tell you from industry, the various industries I've worked in over the many years, in particular the last couple of years, that these particular subjects are really hitting home with industry, particularly your virtualization and cloud computing. Network security and administration is always a big component of any enterprise network. Your risk management is getting a higher profile, and your wireless networking will become more ubiquitous as time goes on. So any of those electives, you get to choose 3, but any or all of them are fantastic options for your professional development. As far as the industry electives go, there's the 4 units there. Obviously the one that this MOOC is tailored to fit into is the practical internetworking. There's also professional system security, which I believe lines up with the CISSP security certification by ISC2. Again, that's that's a very good one to get at the moment. And the managing mail servers and server administration articulate with Microsoft exams. So again, any or all of those are fantastic options to pick depending on which way your career want to go. So as I said, if you've got the CCNA certification already, you can apply for credit for the practical internetworking subject, so that'll give you a head start, a leg up anyway. This MOOC will basically follow the exact course content as will be used for practical internetworking next year. It's just in a slightly more condensed and speedier version, obviously, because of the time restrictions we have. If you've got any other questions about the credit, fill out the eligibility form at itmasters.edu.au and have a look. Okay, I've just seen there's a few questions about the blackness on the right-hand side of the screen. That's it appears to be the toolbar for the webinar, so I'll just push it out of the way. I'm not sure whether that's just a Windows 8 thing or not, but I'll just push that down to the bottom so you can get a bit of a look. Sorry about that. Okay, so we'll just move on. Okay, so Charles Sturt Uni, as you can see from this slide, is a big market leader in distance education, particularly here in Australia. So that's a number of enrolments. So over the last couple of years, so you've got nearly 30,000 enrolments, a long way ahead of whoever's coming second type thing. And look, I can tell you from practical experience, there's a couple of universities on that slide that I've actually done courses through, and Charles Sturt Uni has a great commitment to delivering high quality online distance education to students, so highly recommended. In terms of postgraduate domestic courses in IT, you can also see Charles Sturt Uni and IT Masters are well ahead of the pack. Okay, so again, there's that commitment to providing quality IT certifications at the postgraduate level to not only domestic students but also international students as the need arises. All right, now for more question and answers on course matters, we have our main course administrator, Jason Howarth, will be joining us in week 3. Unfortunately, he wasn't able to join us this week, but in week 3 he will join us and he will go through those slides and a bit more information in more detail. So if you have questions on that, just keep them in the back of your mind and you can bring them up at that particular time and he will be able to answer them as well as possible. If you need to ask any questions prior to that, feel free and we'll do our best to answer them. Okay, so if we now move on to the actual content of the MOOC today. So in overview, we're going to have a look at the Cisco certifications. Just briefly, have a look at the brief overview of that and talk a little bit about the way to get to CCNA and how that articulates with further qualifications. The specific CCNA exam requirements. Now the exam requirements that we're going to look at in this MOOC and in the subject next year is exam 200-120. So that's a new exam that's not long come out. As of the end of this month, it will be the only CCNA exam that you'll be able to do. So the old one, which was 640-802, will go at the end of September. Now the actual content of the exams is not much different. So Cisco have removed some legacy stuff from the new exam and added a little bit more wireless and a little bit more IPv6, taken out a couple of the older routing protocols. But other than that, look, it's fairly much the same. We'll have a look at some online labs. Now this year we're recommending the Cisco online learning labs, and we'll have a look at the labs later on in the session today to give you an idea of what they're like. You know, very highly recommended. They're much better than they were quite a few years ago. Obviously they support all the native iOS commands because Cisco owns iOS, and obviously they're less noise, less expense in having your own rack at home, and they're relatively good bang for buck, so we'll have a look at those shortly. And then just look at some study tips which I think are important for everyone to keep in mind, just to help you study and to help the retention of information as moving forward. Okay, so the certification overviews. So if we have a quick look at this. So CCNA is actually the second level of Cisco certification, and if I just change to my web browser here, we can see entry-level certifications here, the CCENT and the CCT. Now both of those are, you know, for people who are basically got no experience in the networking community and are just starting off in their certification career. So that could be, you know, straight out of high school, straight out of uni, whatever it is, or career changes. Okay, that is really base level networking. Then the associate level, which we're looking at here. So this MOOC will cover the CCNA routing and switching. This is basically, there's some assumptions made, and we'll go through that in a minute, about what Cisco actually expect you to understand to be able to come in at that CCNA routing and switching level. And from what I understand of the cohort here, the vast majority of you would clearly fit into that. You can see that at the associate level there are bucket loads of specializations. Now, almost without exception, most of these require a already valid CCNA routing and switching certification before you can then go on and do any of these specializations. Not all of them. I think service provider operations, and data center don't, but the rest require a valid CCNA routing and switching anyway. So it's the best place to start, and it provides you with foundation routing and switching knowledge that, irrespective of whether you're doing service provider or not, you're still going to use that knowledge later on down the track, so it's a perfect place to start. Also, if we scroll down and have a quick look at the CCNP designations, you can see they've got quite a few specializations as well, and without exception, all of these require a valid CCNA or CCNA specialization before you can even qualify for these. So you can go and do the exams, that's fine, like CCNP Wireless, for example, there's 3 exams in that one. You can go and do those 3 exams, but you won't get the certification until you do the CCNA Wireless. And you won't get the CCNA Wireless until you've done the CCNA routing and switching. So that's the way Cisco work it all out. You start at the associate level. You can come into CCNA without anything, so you don't need to do these exams here, and then you can move on forward through it. And CCIE, they're an anomaly because they're the highest level certification, but you don't need to do any previous certifications before that. You can just jump straight into those. I wouldn't advocate that unless you've had a lot of technical experience, and if you've had enough technical experience and hands-on to do a CCIE, then I'd probably expect that this MOOC's not for you. Okay, so if we drill down on the CCNA routing and switching, because obviously that's what we're going to look at, you can see there are 2 methods that you can gain your CCNA certification. There's a 2 exam option and a 1 exam option. So the 2 exam option is this one here, 640822, ICND1, and then there's an ICND2 exam. The exam we're preparing you for in this MOOC is 200-120. Okay, so that's a single CCNA exam. In my opinion, the single exam option is the way to go. Simply because it's around about 65 to 70 questions. These two exams are also 65 to 70 questions. So in effect you answer less questions, it's less expense, but the level of detail that you go to is exactly the same. Okay, so instead of getting maybe 7 or 8 questions on routing technologies, you might get 3 or 4, and then you can move on to the next topic area, because every topic area, as we see in a minute, needs to actually be covered. So if you've got absolutely no network experience at all, then you would probably come through the CCENT certification. Once you got to the CCNA, you could do the 2 exam options if you wanted to, but look, 99% of people, in my experience, have been able to successfully negotiate the CCNA exam without the need to drop back. Now, just to make a note of this, okay, last day to test for the old exam is 30th of September. Now, if you've come into this MOOC hoping to use this as preparation for the 802 exam, that's fine. Obviously, that's only in 12 days' time that it cuts off. The content that we'll be covering up until that stage articulates perfectly with that anyway. But obviously later on, the later sessions, weeks 4 and 5, will concentrate more on some of the new stuff that's come into the new CCNA. But either way, you'll be pretty much covered. Okay, so if we just jump back to our preso. As I've said, go straight to CCNA, lots of experience. This is a web link that I was just on then, okay, for the certification. So if you're interested in finding out more information about the certifications and how they articulate to each other, then please have a look at that link. Okay, exam 200-120, current exam 802 retires end of September. We've already talked about that. We're following the new exam topics, but this will prepare you for the 802 exam anyway. Now the outline, our outline for the exam is on the IT Masters portal, but I've also got it here. Okay, so this is the official exam outline from Cisco. You'll see the exam topics, operation, IP networks, everything's in there. So I would urge you to have a look at this. The basic principles in this and a lot of the concepts in this we will be covering over this 6-week course. Obviously, those 6 weeks, unless you've had a lot of experience, 6 weeks is not going to be sufficient amount of time to prepare for the exam unless you do external study as well, your own study outside these classes. So have a look at this PDF, have a look at the topics and the technologies that you need to know about, and use the extra resources that I post up on the portal as we go along. Okay, and also in web link there, in web link format, if you want to get straight to that PDF, it's available there if you don't want to get it off the IT Masters link. Now, just an interesting note, a CCO login, okay, so that's a Cisco Connection Online login. If you go to www.cisco.com or cco.cisco.com, 95% of the resources that I'm going to be using during this MOOC will have come from there. Okay, simply because, in my opinion, Cisco have got the best support site for their technology of any company in the industry. All the resources and links that I will post don't require a CCO login, okay, so they're available to anyone if you haven't got one. If you have got one, either you're a reseller, integrator, or you're in enterprise space and you have a support contract with Cisco, you will automatically have one. You can also get a free one, but obviously you won't be able to download iOS or get any support for anything. But if you get a CCO login, you will get a lot more information than what you will get just through the public sort of side. So I would suggest and recommend that you get a CCO login, just because, even not for this MOOC, but just for later on in your professional development, you will get a lot of benefit from it. So even though they cover most things in Cisco-specific talk and, you know, Cisco's way, it's Cisco's way or the highway type thing, they still cover a lot of the basic networking theories in excellent detail, and they're, you know, fantastic resources. Okay, you'll just get the black screen back for a little second. My apologies. Just want to separate and have a look at some things. Okay, so I've got a question just about some free online labs. There are some free online, which beautifully segues into this, of course, so lovely question, Dinesh. There are some free online labs, but as with anything in the networking place, you'll get what you pay for. Okay, so the labs that I'm just going to go through now, quickly have a bit of a look at, are $79 US, and you'll see that they are later on in today's webinar. You can see that they really are very well worthwhile the money if you don't have access to Cisco kit as it is. Okay, so they're the Cisco Learning Labs based on the Cisco ICND curriculum. As I said, I highly recommend them. This particular link here I think goes to the more expensive version. So if I show you the ICND labs in specifics, okay, so this is the one here, these are the ones here I would recommend. So that's for ICND 1, so that's again, that covers, both of these lab exams cover a specific, one of those specific 2 exam options, yeah. So we've got the ICND 2 one, and then we've got the ICND 1 version 2 course, and then the ICND 2 version 2. So for $79, you basically get 35 hours over a 90-day period. So in that 3 months, you've got 35 hours access, and you can use them at any time. Okay, so if we just briefly scroll through, if you have a look at here, and again, sorry, these links for these are here on the Moodle site, okay, under Week 1 Introduction Basic Networking, links are there. These cover a lot of, they have specific exercises that cover a lot of the technology that you'll be tested on in the exam. So there won't be everything. You'll need to do supplementary reading and attend this MOOC and other things, but as a way of getting hands-on practical experience, these are fantastic if you don't have access to Cisco kit. Now, even if you do have access to Cisco kit, I mean, I know over many years of study that sometimes, yes, you have access to Cisco kit in a production environment, but you don't use particular technologies. Like, for instance, I'm not sure if too many people are using IP version 6 full on in their enterprise networks. So it may be difficult to get exposure to that even in a work environment, even if you do have access to it. If you work in integration space, then you're probably in a bit better spot to get that sort of experience. But again, for $79, it's good bang for buck. And as you'll see later on, they are really good labs. So the exercises they set for you, give you specific steps that you need to work through. They're fully compatible with all Cisco iOS commands. So it's not like in the old days where they'd ask you to do something and you'd only be able to type in 1 or 2 commands and that's all you could do. You can use the question mark. You can pretty much enter in any old Cisco command you want. You don't even have to follow along with the lab if you don't want to. So I think they're well worth it, but obviously that's up to you. But I would certainly recommend them and say they've come a long way since the last iteration of the labs that I looked at. Okay, now study tips. I'll put all these up at once because I think these are really worthwhile digesting. So I'll get through them nice and quickly though. So the first thing is, not just through this MOOC, but through all your study experiences, test yourself instead of rereading your notes over and over and over again. And this is a thing they call in psychology retrieval practice. Okay, so with the MOOCs, you might download the PowerPoint PDF. It's got some note space on it. As you're going through the recording, write down your notes, fine, reread your notes a couple of times, but then practice retrieving them, okay? Ask yourself questions, okay? So that again segues into point 2. Test yourself repeatedly until it kills you. So keep asking yourself questions, verbalize it, talk out loud to yourself or a friend. What this does is that, often you might have something in your mind and you're thinking about it, but then verbalizing it, you say something else or you bring out and you think, oh, hang on a minute, I hadn't thought of it that way. Okay, it triggers off the building the links between the neurons in your brain for this knowledge, so it commits it to long-term memory. An important one, distinctiveness. So think about how what we're learning is the same or different to something else that you know about, or even how they compare and contrast to each other. So for instance, look at VLAN trunking and ether channel trunking. How do they compare? How are they the same? How are they different? Okay, talk that out loud, think about it, and that'll really help to solidify your long-term memory. Apply it to your own experience or your own workspace. Okay, so if we're talking about, say for instance you work in a large enterprise network, you're the WAN guy, and the LAN guy over here doesn't use VLANs. We're learning about VLANs. You think, okay, how could that help us build a better internal network for our enterprise? Apply it to the experience you've had in your own workplace and use that knowledge to build your memory up. Okay, beware of familiarity. Okay, I can't stress this more. I mean, I've done this plenty of times over my career too, is that just because you're familiar with something or have seen it before doesn't mean you really know it. Okay, so the only thing that's going to get you to know it is practice, 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 or read, read, read. Okay, constantly talk about it, immerse yourself in the technology. So don't just read about something, become it. Really get in there and be keen about it. And it's amazing how quick you can pick this sort of stuff up, particularly if you've got a background or if you've got a real interest in something, you'll pick it up really, really well. But I mean, I know plenty of times people have said to me just throughout my career, hey, BGP, can you do path prepending? Yeah, I know how to do that. I sit down, hang on a minute, I need to look this up. Because I was familiar with it, I didn't really know it. And then the last one, read and study extensively. Okay, so the resources I'm putting up are useful. There are more on CCO that you'll be able to get with your CCO login. But at the same time, don't just rely on Cisco stuff. Have a look at stuff from Juniper. Have a look at stuff from HP. Have a look at old stuff from 3Com, universities that you've been to. The basic underlying theories of networking, whether they're IP, DNS, SMTP, whatever they are, the underlying protocols and technologies are all the same right across the industry. They're no different in a Cisco spot to where they are anywhere else. You just need to read and understand the underlying theory. If you understand the underlying theory of how to route, how to switch, what OSPF does, what BGP does, then you'll be able to easily go to any vendor's piece of equipment, use their question mark or their help guide and work out what commands to do to implement that technology. You have to understand the underlying technology first. Obviously in this MOOC we have to be a little bit more pointed towards the Cisco side of things because it's specifically for a Cisco exam, but in general I'm saying get out there and read a lot of other stuff. Okay, let's go into the week 1 topics. We're going to look at some networking basics. So devices, applications, OSI reference model we're going to spend a fair bit of time on. People find it dry, but honestly there's not a single day in my networking life where I haven't used it. Okay, it's really important to understand and you'll see why as we get into it. A bit of a look at media, cables, ports and connectors. There's not really much to understand there. It's pretty straightforward. Quick look at VLANs and I'll do a lab and some examples of that. Then we're going to have a look at some LAN switching, so basic switching concepts, difference between hubs and switches, what they do, and layer 2 and layer 3 with respect to VLANs. Now, if you don't understand layer 2 and layer 3 at the moment, don't worry, we're going to cover that in the OSI reference model in a minute. Okay, so some assumptions that I'm making and also Cisco makes with respect to this exam. So they assume that you have some knowledge of LAN, WAN, MAN terminology. So in other words, you know that a LAN is a local area network, a WAN is a wide area network, what the difference is between them, how they span different geographical locations. So a LAN is generally in a single building or a single campus, although sometimes that's called a CAN, a campus area network. And that WAN is for connecting across vast distances. So it could be international, interstate, even same state, different cities. A MAN terminology, so a MAN is a metropolitan area network. So that's basically something that would connect multiple buildings within a single city, but they may be in different suburbs. Okay, so a perfect example of that where I live is I've got a very large regional bank here that has 2 data centres separated by a fair bit of distance, hopefully, in suburbs and a couple of main campuses, and they have a direct fibre connection running over a technology called DWM between all of those, and that's classified as their MAN. Okay, there's an assumption that you know some basic binary math. So 1 is on, 0 is off, that you know that 101 is 5, that you know that the basic operations of AND and OR, okay, the AND and OR logic. if you're not quite up with that, it's not too bad. We'll cover that a bit more in detail next week when we're looking at IP addressing, because that's when you're really going to need it. But there is that assumption that you understand some basic binary math. And also some general internet knowledge, okay? So you know what DNS stands for and what it does. So domain name system converts nice friendly names into IP addresses, okay? HTTP, the main web protocol. HTTPS, secure web protocol. FTP, file transfer protocol, okay? What it does, what it's used for. And SMTP. So, and they're just some examples. There's many others that we'll come across, but there's that understanding that you would have at least a rudimentary knowledge of what those protocols are and what port numbers they are. Okay, and if you've got that, you'll cover off a heap of questions in the exam. Okay, so let's have a look at some networking basics as per the actual exam guidelines. So there are three main types of network devices which are useful for comparison and getting our head around what networking is and the OSI model. Okay, so there's hubs, there's switches and bridges, which are basically that terminology is now interchangeable, and there's routers or layer 3 switches. Now again, routers and layer 3 switches from a kit list and a hardware perspective are slightly different, but from a functional perspective they basically do the same thing. And this web link here is actually a really good one, even though it's not a Cisco one. Ask Leo. I don't know who Leo is, but anyway, some of you guys may know who it is. What's the difference between a hub, a switch, and a router? Pretty obvious what that's talking about. So if you have a look at that, that will give you a Cook's tour of what the difference is between the three. And it's worthwhile having a look at simply because it's abstracted from any of the vendors, so you don't have any vendor bias on it. But anyway, hubs. So they are legacy. They're rarely seen, I hope. I hope most of you don't see too many hubs, but they're useful for comparison. And the reason they're rarely seen is because they have these two constructs called a single broadcast domain and a single collision domain. Now, it doesn't matter if you're not quite sure what they mean at the moment. We'll cover that as we go through it. Okay? But basically, a broadcast in a network is a packet that goes to all hosts on the network. So all hosts, whether they be PCs, printers, servers, disk arrays, whatever they are, have to stop and process that traffic, okay, which takes CPU cycles, which takes up bandwidth on the network, takes up resources for the switches and routers, okay, so broadcasts are generally a very bad thing. Hubs only allow you to have one broadcast domain, and what that means is if you have, say, a 24-port hub, any packet, any broadcast packet that goes in one port will automatically be distributed out all other ports. So everyone gets to hear it whether they want to or not. Okay, single subnet, single broadcast domain, doesn't scale very well, very ugly. It's also a single collision domain. Now, collisions are a leftover from the old half duplex days, okay? In a lot of networks now with full duplex, collisions are less of a concern, but collisions occur when a packet is sent out onto the wire at the same time as another packet from another host is sent out onto the wire, and they basically physically, electrically, crash into each other and become damaged in some way. Okay, so then that creates all sorts of havoc because the packet hasn't been delivered. There's no acknowledgement coming back saying yes, I got your packet from the destination host. It's got to be retransmitted again, and there's really old school stuff that we could go into about algorithms that back that off. That's not sort of really needed for this level of the exam, but the collision, that's what a collision domain is, okay? So it's an area where packets can collide, and in a hub there's only one of them. Bad. It's a layer 1 device, so what that means, which we'll have a look quickly in a minute, we'll compare that to the OSI model, and you'll see that what that basically means is it works at the physical or electrical layer of computing. Okay, so it doesn't do anything clever. Packet comes in, it sends it out another port. Simple as that. Okay, switches and bridges, ubiquitous. They're everywhere. Okay, now these are the most common network device you will have to configure in your career. Everywhere. Switch and bridge are interchangeable terms. In the old days, bridges were a little different. When switches first came along, now the terms are interchangeable. So if I say switch, I mean bridge. If I say bridge, I mean switch. Doesn't matter. So don't get put off by that. Again, it's a single broadcast domain. Okay, so this is the same as a hub. Broadcast packet goes in, One port goes out to all other ports. But it has many collision domains. So if you have 24 port switch, you have 24 collision domains. This means that the collisions are limited to each singular port. Okay? So and each host is connected to a single port. So if I have a collision on that link, it means that only that host or only that conversation is affected, not everyone else on the switch. So you can see how that would really drop down the amount of CPU processing that the switch has to do. So many collision domains, big step up from hub, but still single broadcast domain. And these guys are a layer 2 device. Okay, so they work at the next layer in the OSI model, which I promise we'll have a look at in a second. And it's basically where VLANs live. Okay, so you'll see how VLANs work later on in the day and later on as we go through. So routers and layer 3 switches, the last one we're going to look at, again, routers, layer 3 switches, pretty much interchangeable. In service provider, the space, or in SOHO, so small office, home office, you can get little baby Cisco routers, which I don't really call routers because they're so tiny, 800 series, 1900 series to a lesser extent, 1801s, that sort of size, which are just routers. They're not layer 3 switches. So all they do is route. A layer 3 switch is something like a 3750 or a 6500 or an 8500, so these are the big iron that go into big enterprise networks or service provider networks, and they've got a bucket load of ports that they can aggregate lots of connections into. So that's the switch part of it, and then the routing part of it is the part that separates networks. So these guys are the ones that have many broadcast domains. Okay, so routers stop broadcast propagation across your network. So that is an awesome thing to do. The less broadcasting you got in your network, the much better it will perform. They also have many collision domains. Okay, so every single port, every single switched port on your layer 3 switch is a collision domain on its own. So again, collisions are limited to one particular host. So that's great, best of both worlds. And as I said, they're a layer 3 device. Okay, so the router works at layer 3, which is where TCP/IP lives. Okay. Should say IP more correctly lives, IPX, AppleTalk, those sort of protocols, not that you'll see too many of them nowadays. A layer 3 switch is a layer 2 and layer 3 device. Okay, so it does a little bit of switching, a little bit of routing, so it's a bit both ways. And as I said before, many of the Cisco switches are layer 3 compatible. 3750, 6500s, 8500s, a CRS, blah, 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 goes on and on. Bucket loads of them, absolutely bucket loads of them. Okay, sorry for the blackness for a second. Okay, excellent. Okay, so I'll move on to the next slide. Okay, this is the big one, guys. This is the one that will give you nightmares. No, seriously. This is the one that we'll spend a lot of time on at the moment and will hopefully build up a lot of your understanding. Okay, so this is the most used model in networking, and I cannot stress enough, do not underestimate its usefulness. I remember when I was at uni as a young bloke, I attended a lecture one day where the lecturer was talking about this OSI model. I thought, oh man, why do I have to listen to this? This is boring old pile of gunk. I'm never going to use it. Wrong. I've used this every single day of my networking life. If you don't understand the OSI model, you are so far behind the 8 ball in terms of doing anything in networking, it's just not funny. So you must understand the OSI reference model. Even though you may not necessarily get single questions about this on the exam, every single question will in some way refer back to the OSI model. We will require an understanding of the OSI model to be able to fully understand the question and to be able to fully come up with an answer. Okay, so it's really, really important. So the key concepts are, and it's pretty simple, there's 7 layers, and you'll see a diagram in a minute which will blow your mind, but 7 layers. And it's a framework for all network communications, starting from the electrical specifications needed to get packets out on the wire, all the way through to the methods for applications to communicate to each other. Now, by applications, I don't mean things like Word and Excel and Outlook, although Outlook's a little bit. I mean more things like DNS, FTP, SMTP, so those protocols that plug into things like, Word and Excel to be able to print something to a network printer, to save to a network drive, to resolve a name, to verify security parameters, all those sort of things. Okay. Okay, I just had a question that I'll answer out loud. I've got a question about a single broadcast domain if we're using the same VLAN, and that's correct. If you're using, thanks Angela for that, if you're using a single VLAN, that is within a broadcast domain, correct. And we'll see later on as we go through into routing, which is week 3, we'll see that in order to be able to route between VLANs, you need some sort of layer 3 device, which of course, layer 3 devices, routers separate broadcast domains. Just another question I'll just answer to is yes, the content covered in this course is coming from the new CCNA exam. Okay, here it is. Here it is. This is a cracker. So this is the OSI model. Okay, now there's a lot of noise on this diagram. I understand that, and we'll try and step through it as best we can. If you have questions, just shout them out, and either James, I've got a fellow organiser on here, James, who might be able to answer some of the questions. If you can't, I'm here to answer them as well. So there may be a few questions out of this, so feel free to pump them through. Okay, so as I said, there are 7 layers in the OSI model. As you can see, 1, 2, 3, 4, 5, 6, and 7, so on. Okay. Each of them is specifically tasked with a particular area of network communication. So as you can see here, the physical layer is concerned with transmission and reception of the unstructured raw bit stream over the physical medium. What? What the hell does that mean? What it means is basically it is the way that a information gets from your computer is converted to a digital signal and sent out onto the wire. That's what it means. Okay, so it's basically data encoding. How is the information taken from a stream of ASCII characters, so like A, B, C, D, E, F, G, converted into binary and then transmitted out onto the line? Okay, it also defines the physical medium attachment. So what that means is, are you connecting via fibre, via cable, at 100 meg, at full duplex, whatever? Are you using baseband or broadband transmission? Okay. So basically, are you sending 1 bit at a time, or are you sending multiple bits at a time? Okay, and the transmission bits and volts. So okay, so what voltage means it's a 1, what voltage means it's a 0. Okay, that's what the physical layer is responsible for. Okay, so not, it seems a lot, but not really a lot. And as it says here, devices and protocols. Woohoo! There he is, Mr. Hub, lives at layer 1. It also says here LAN-based layers. Okay, so they're things like your the IEEE specifications for things like Ethernet, token ring, and token bus. So you think token ring, token bus, geez, I'm showing my age there. But basically Ethernet now, so 802.2, 802.3 standards. Just for interest's sake, just a little corollary here, you don't have to know too much about the IEEE standards to do the Cisco exam, but it's kind of funky to go and look it up. Okay, particularly if you're having a bit of a slow day, got nothing else to do, have a look at IEEE.org and have a look at the Ethernet standards, or the networking standards, which are 802. Something. So 802.2, 802.3 are Ethernet standards. You've got 802.5, you've got 802.11, all the 802.11, which are all the wireless standards. It just goes on and on and on. So have a look at those. Okay, the data link layer says it provides error-free transfer of data frames from one node to another over the physical layer. Oh man, why don't they make this easy? What they're basically talking about there is this is where your network interface card, or network, so they've got NIC card, that's network interface card, don't like that, but anyway. So network interface card to switch to network interface card, so end to end. So you're talking about 2 hosts connecting through a switch here, and the data link layer is responsible for all these little things here. So it establishes and terminates the logical link between the nodes, does that by signaling. Frame traffic control, so things like, collisions, making sure that a frame gets out on the wire and comes back without whacking into each other. Frame sequencing, so that's making sure that the information that you're trying to send out on the wire goes in the correct order. So for instance, if you've got a sentence with 10 words in it, let's say for argument's sake that each word fits into a nice little packet, it sends the first word first, the second word second, the third word third. Obviously, if you change the order of the packets around, then you can change the whole meaning of the message. Frame acknowledgement, that basically says, yep, I got the frame from the source that sent it to me, no worries, ready for the next one. Frame delimiting, okay, that's cutting down the size. Where does the actual frame end? Where does the, and you'll see in a minute the process of encapsulation, so where does the layer 2 finish and where does the layer 3, so the next layer up begin? And media access control, so that's what I was saying before with the collisions. There are some protocols. One of the most commonly used one is called CSMA/CD, and that stands for Carrier Sense Multiple Access with Collision Detection, or CA, collision avoidance. So what those media access technologies do is if they detect a collision, they'll basically listen to the line for a certain amount of time. When it's free, they'll start the transmission again. Okay, in a nutshell, that's what they do. And we'll have a look at that in a little bit more detail later on. Okay, network layer 3. This controls the operations of the subnet, deciding which physical path the data takes. So all that's basically saying is this is where our old mates, the routers, live. Okay, and our broadcast domain. This talks about logical to physical address mapping. Okay, so logical to physical address, what the heck is that? Well, a logical address is a protocol address, so like an IP address, an IPX address, or an ICMP type. Okay. Down here at the data link level, where I neglected to mention that the switches live there, the addressing that's used at the data link layer is the MAC address of the actual network interface card of the device. Okay, so hopefully all of you have seen a MAC address. If you haven't, we'll look at one in the not too distant future. The network address here is what's mapped to the MAC address there. Okay, so that's where that happens. The mapping of protocol addresses to MAC addresses happens at layer 3, as does routing. Okay, that's the main thing that happens there. And things like traffic control, frame fragmentation, those sort of things happen at network 3. And again, we'll dive into those more as we go along. Okay, the transport layer ensures that messages are delivered error-free, in sequence, and with no losses or duplications. Okay, so message segmentation, cutting messages, cutting packets up to suit the physical limitations of the actual segment, okay, the actual transmission medium. So for instance, in Ethernet, there's a maximum theoretical size of around about 1500 bytes. So if the packet you want to send so the message you want to send is bigger than 1500 bytes, which most of the time it is, then you need to chop it up into nice little 1500 byte segments and send it off. Message acknowledgement, again, that is specifically a TCP, okay, so transmission control protocol. That's part of the IP, so TCP/IP. TCP is connection oriented, so in other words, if I send a packet, it has to be acknowledged before I send it back, before I send the next one, okay. There's another protocol which also lives at layer 4, which is called UDP, User Datagram Protocol. That is connectionless. So what that means is I just send a packet, so I don't care whether there's acknowledgement or not. I just send it out, and hey, if it gets there, well, that's fantastic. So that's TCP. Okay, as you can see here with this little pink bit here, we've got packet filtering, which just lives in here. Okay, so that's where you do your things like your access list, also your quality of service, which is outside the scope of CCNA. Access lists aren't, basic ones aren't, but QoS certainly is. That's where you would apply it here at layer 3 and layer 4. Okay, the session layer allows session establishment between processes running on different stations. So you've got to remember that if you have your web browser open on your workstation, it doesn't directly talk to the network itself. Okay, it talks with this session. So your protocols like your RPC, your SQL, NFS, NetBIOS, all those sort of things, you know, DNS, all that sort of stuff, talks over the session layer to get the communications up and running. Okay, so session establishment. Okay, can we start the conversation? Let's keep it going. Maintenance and termination. Okay, we're finished. Bye-bye. There's also some security components here and logging as well. The presentation layer formats the data to be presented to the application layer, okay, to be presented to the application layer, the upper layer. it can be viewed as a translator for the network. So as it says, this is basically like the language, this is like an interpreter. Okay, so it converts because you can have multiple hosts, multiple protocols doing all sorts of different things on your network. Okay, a network is not a one-size-fits-all. It's very homogeneous. There's lots of different things out there, lots of different formats. So the presentation layer is required to translate or encrypt and decrypt if needed between these sort of different protocols. Okay, ASCII, EBCDEC, TIFF, GIF, PIC, JPEG. Okay, there's a myriad of others which many people know about. And then lastly, the application layer, which serves as a window for the applications on your workstation or your printer or your server to get their messages down the chain out to some other host. Okay, so it's resource sharing, remote file access, printer access, directory services, network management. Okay, SMTP, SNMP, SMB, all those sort of things live there. Just as an aside, just over here on the side here, there's this DoD4 model. Okay, DoD4 model is not really a competing model, but it was a model that was brought out quite a few years ago by the Department of Defense that sort of broke things into 4 layers instead of 7. And these articulations here are roughly how they match up to the OSI model. Okay, you won't tend to see too much of the DoD4 model. OSI model is obviously the dominant one, but if there's any reference to it, it's just nice to have that comparison there. Okay, so there's a little bit of overlap between it. Okay, just to answer another question here. Does Cisco focus on TCP or does it expect you to have a good understanding of SPX2? And that's from Tim. Thanks, Tim. No, TCP/IP only. There is no need to worry about SPX, AppleTalk, anything else. It's pretty much all IPv4, IPv6. That's it. All those legacy protocols have long gone, but they're useful just to show them on the OSI model as a way of understanding how the whole thing works. Good question. Thank you. Okay, this is, I promise, I think, this is the last diagram we're going to go through on the OSI model. So make sure, please stay awake, stay with me. Understand this is dry stuff, but we'll try and get to it. Okay, so what this diagram is demonstrating is the process of encapsulation and the idea that each of these layers only talks to its opposite number on the other client side and the layer directly above or below it. That's all it talks to. Okay, so for instance, if we look on the client A side here, the physical layer only talks to the physical layer. The physical layer on client A only gets to talk to the physical layer on client B. Okay, and the data link layer on client A. That's it. So the physical layer doesn't talk to the network layer here, doesn't talk to the application layer over here. Okay, it's all strictly, if we're sending information from here, so data, I'll make data, it flows down the tree that way, gets encapsulated, it transmitted out onto the line, across to client B, then it flows back up the OSI model. So this process is called encapsulation. So if we have a look at how it all works for a start, okay? So we'll work back this way. So we're pretending we're sending some data. So here's our data. We're sending it, it's flowing down the tree. So the data, say from, let's say it's a web request. So we type into our browser cco.cisco.com. That request, now there's a lot of things that happen in the background with DNS resolution, but we won't go through the whole string. But let's say that DNS is already in cache, it already knows what cco.cisco.com is, it's going to take that HTTP request and that's the actual data. The sending host sends it down to the application layer which puts an AH on it. AH, application header, that's all it is. Okay, so it puts a header on it to say what is following is data. This is the application header, what is following is data. Okay, it then sends it down to the presentation layer which, whoa, guess what? It adds its own header on, presentation header. And I think you're going to get the idea fairly quickly. It does this all the way down the stack. So session, session header, transport, transport header, network, network header. Now, session, presentation, application are probably not unless you work specifically in security or maybe a little bit in voice and maybe a little bit in wireless, not going to have an awful lot to do with. This is where a lot of security, deep packet, shallow packet inspection happens up here. Okay, but down here, transport layer, network layer, this is where the bulk of our work is done as networkers, yeah? So the transport header is where things like port numbers first come in. Okay, so TCP, UDP port numbers. So for instance, in this case, because we're doing a web request, it would be using the HTTP protocol, which is a TCP port. So it's a connection-oriented connection, so TCP. It has to send a packet out, get an acknowledgement back before it sends the next packet or next group of packets. And its port number, for those that don't know, is port 80. Okay, so TCP port 80. Then once that transport header is appended, it sends it down to the network layer, and this is where our network addresses start to come in. So in this case, it's basically the source address, the source IP address, and the destination IP address. Okay, because without those, you've got to know where you came from, you've got to know where you've been. Okay, so where you're going. So, so the packet can get across to the destination, and then on the way back, can get back to the original sending host. And then shoots it down to the data layer. Okay, so the data link layer then does the whole MAC address transformation. Now, how it does that, we're not going to cover today, but we will later on in the MOOC, okay, about the actual process of taking an IP address, resolving it to a MAC address, and how that changes in a routed network compared to a switched network, okay, because it's very different. And then lastly, we send it down to the physical layer, which doesn't add a header, but it converts it into bits and bobs and bytes and pokes it out across the line. Okay, so it travels across the line and then gets back to the physical layer on the receiving process, and the direct reverse is then done. Okay, so it gets to the physical layer, it passes up to the data link layer, which strips off the header and the trailer. Okay, and these contain information too. The trailer contains information about frame checks and that sort of thing to make sure that the packet got there okay and it's not damaged. Now the reason that happens early in the stack is because obviously the higher in the stack you go, the more time it takes and the greater processing power it takes. So the earlier you can do those sort of checks, the better. Then it sends it up the network layer, strips off the network header, sends it up the transport layer, strips off the transport header, session layer, so on and so forth. Now as it goes up, back up the stack, it does a series of checks. So as I said here, when it gets to the data link layer, it checks first of all, is the MAC address that's in this as a destination MAC address, is that my address? So is it for me? Is it my mail, basically, or is it my packet? If it is, it then sends it up to the network header. It says, okay, is the destination IP address, is that my IP address? Yes, it is. Okay, I'll take it. If it's not, drop it, go away. Then goes up to the transport header. And in this case, this is important because in the transport header, remember, it's got the fact that, okay, I'm a HTTP port address, so I'm a TCP port 80 request. So this end host, which hopefully happens to be cco.cisco.com if all our routing and that's working correctly, it will say, okay, well, I know the address is for me. Okay, I'm listening on port 80. Good, I'll send this packet to my port 80 process. Then it goes up to session, presentation and application, stripping off the headers, doing all the checks and balances until it finally gets to the receiving process, and it then says, okay, you want information for cco.cisco.com, here it is. And the process reverses. So it takes that information, segments it down through the OSI model into the packets, sends it back across the line, back to the what was the sending process, which is now, of course, the receiving process because the conversation's going the other way, and away it goes, backwards and forwards, once your session is established. Okay, so hopefully that gives you a basic idea of how the packet flow goes from side to side. Remember, the communication is peer-to-peer. So what I mean by that is application talks to application, presentation to presentation, session to session, between two hosts. Within a host, each layer only talks to the layer directly above it and directly below it. Okay. So next one. Okay, so going past the OSI model. If you have any questions on the OSI model and you haven't already asked them, which doesn't look like there has been, so maybe everyone's gone to sleep, and I wouldn't blame you if you did, simply stick them onto the forum or email them through, preferably on the forum, and that way everyone can share them. Okay. There's a lot of stuff to digest. There is a resource on the Moodle site already to do with OSI model, so have a look at that. If you've got any questions, post them and we'll cover them, because I understand there is a lot of information in there. It's a complex thing, but really important to understand it. Okay, so media, cables, ports and connectors. There's not a whole lot we need to really talk about here in terms of the exam, but we'll definitely go through some of it anyway. So what does this even mean? Well, it means how we connect to things, okay, how we physically connect to things. So we don't need a detailed knowledge, but you do need an understanding. So you need to understand the types of cables and connectors available and how they interconnect with devices and hosts. And what I mean by that is that you can get, you can obviously get copper connected ports or modules. Okay, so Cisco kit comes in a couple of different versions, well, a couple of different flavors. One is a fixed port configuration, and those particular devices have a certain port on them that you can't change. Okay, so they may have a copper port on them. So that's your typical RJ45 plug. They may also have, those fixed port configurations may also have some what's called SFP ports or module ports. Okay, now if they have module ports, you can often buy fiber or copper modules, well, I'm not sure why you want to buy a copper one, copper or fiber modules that you can plug into those ports, and so they can be either one. It doesn't matter. Okay, the speed is normally fixed, but the actual port itself is interchangeable. So you need to understand the difference that there is fiber and there is copper, and that there's even some wireless interfaces and some other funky stuff that's coming out. So you need to know, about RJ45, which I'd be very surprised if most people didn't. You need to understand crossover and straight-through cables. You need to understand fiber connectors, and that you can't connect a fiber connector directly to a copper connector. Okay, it doesn't work. Not going to work. Electrically, they're totally different. One uses electrical signals, the other one uses pulses of light. Okay, totally different. So you need to understand that. Okay, copper and fiber, as we just said, CU, copper, fiber in the main. Okay, they're the two main things that you're going to be looking at in the CCNA exam. There's lots of different fiber stuff in terms of single mode, multi-mode. There's different frequencies, there's different wavelengths, there's all sorts of stuff that you could go into, and that's a whole topic in itself, and indeed a whole exam on itself. In fact, I think a big slab of the service provider stuff is devoted to that. But for CCNA route switch, no worries. All you've got to worry about copper and fiber. And crossover and straight through. So understand when you need to use a crossover and when you need to use a straight through cable. Many of the Cisco devices now are auto detect. So if you put in a crossover cable where there shouldn't be, it'll just go, nah, don't care. I know what you mean. And it'll reverse its pinouts on the actual port itself, and the electrical connection will come up and everything's hunky-dory. You'll get that on most of the more expensive models, so say from 2900 series switches and up. Anything below that, it's a bit of, bite your tongue and see whether it's going to work. It's not always consistent within the platform types. It's not always consistent within the iOS versions either. So you just need to play and muck around with that. But for the purpose of the exam, understand that if you are connecting like devices together, so PC to PC, although what's the point of networking if you do that, switch to switch or router to router, you will need a crossover. Okay? If you're connecting different devices together, so router to switch, switch to PC, then you will need a straight through cable. Now, the only exception to that is router to PC. If you were to directly do that, and there's not many cases you would do that, but if you were, then you would have to use a crossover cable, because they are both, for all intents and purposes, considered to be similar devices. Okay. And as I said before, like for like. Now, if you've got copper, you've got to bang copper into it. If there's fiber, you use fiber. Okay, that's what you're going to use for. Okay, couple of questions have come through. Okay, Tim again. Thanks, Tim. Do you need to know the wiring, i.e. wire color pinouts? No, you do not. Okay, not for the exam. For knowledge and for ongoing in your career, absolutely. For the exam, no, not at all. Next question from Christian. SFP plus transceivers something that will be discussed? No, we don't need to discuss that. There are some resources that I'll put up later on in the course that will show you the differences and what this SFP does and what that SFP does. But in terms of what the exam does, what the exam tests, you don't need to know that. Okay, and last one, match the hardware and transceiver ports. So for instance, if you've got a 2950G switch, the switches on the far right hand may be copper or fibre, whatever they are. Let's say they're all copper. You've got the copper version. They are gig only, okay, only gig. So if you then go to try and plug it into a 100 meg port, guess what, it won't come up. Okay, so you've got to match hardware not only in terms of physical, copper to copper to fibre to fibre, but also speed to speed. Duplex is not such an issue, okay. Gigabit, but the speed, gigabit to 100, and God forbid if you've got 10, they can, okay, cause some problems. So just be aware of that. Also be aware that there's a lot of cables that I've seen that are floating around that are only used, that have only got 2 sets of wires in them, so they've got 4 wires in them. They won't work on gig. You must have an 4-pair or 8-wire cable to work in gig. If you don't have that, it won't come up. So just be aware of that. In terms of the exam, look, I would be extremely surprised if you got a question that was asking you to plug, different transceivers in and go gig to 100. It's just not going to happen. I'd be absolutely amazed. It would be way off the ballpark. And if they did, it would very likely be more as a research question than it would be an actual assessable one. So yeah, don't worry about that in the slightest. Okay, as I said, speed, mostly AutoSense in the enterprise space, which basically means you can take your crossover cable, your straight through cable, you can plug one end into a switch, one end to another switch, bingo, they'll come up, they'll be happy, they'll say, all right, what speed are you going to work at? 100? Yeah, I'll work at 100. What about gig? Yeah, I'll go gig, bingo, it'll come up, and the duplex will go as well. Okay, so they'll say, you full duplex? Yeah, I'm full duplex. Okay, bang, off they go. Everything's fine. But that's not always the case. So best practice, and you will see a bit of this on the CCNA exam, best practice as far as Cisco is concerned is to nail up on non-gig links. Okay, gig is a different standard altogether, and it's extremely unlikely that it won't detect correctly either speed or duplex, unless of course you're plugging into a 100 meg port, in which case it's, may not rate limit down. But where you're talking about 10 meg or 100 meg connections, I would advise you to always set the speed and always set the duplex in an enterprise environment. Now in a provider space, that can be different, okay, depending on your provider. So Telstra, for instance, have a number of different NTUs, which are basically boxes that provide service from their network to an enterprise network. If you plug your router into that, sometimes you need to nail the speed up, sometimes you don't. Okay, I'm only saying this to demonstrate the fact that speed and duplex is something that you need to be aware of, not only in the exam but also in the real world. Okay, if you don't get the speed right, in this case, your links will be inoperable. Okay, so if you've got a gig port that won't go below gig and a 100 meg port only, they won't talk to each other. There is nothing you can do. You just have to get the right port. They have to match in speed, otherwise it won't work. Duplex is a little different. Duplex will, if you have a duplex mismatch, so you've got full duplex one end, half duplex the other, your connection will still work, but you'll get abysmal performance. Okay, full duplex is always preferred in the standard. So if things are auto-negotiating, they will try to go to full duplex. If it's not supported, they fall back to half duplex. Okay, and all that means is half duplex means one side at a time. Only one side can communicate at a time. Full duplex means both can send packets at the same time. Okay, so that's all that basically means. If mismatched, you'll get really crappy performance. That increases with throughput. So the harder you try to push the port, the worse it will actually go. And you'll get packet errors at the half duplex end, but you'll get those anyway with half duplex connections, so you may not see much. But at the full duplex end, if you have a look at the interface stats, you'll see bucket loads of late collisions, okay, heaps of late collisions. And late collisions are basically a collision that occurs after the 64th byte in a packet, okay? And we'll talk about that shortly. So how we move on? Okay, copper connectors, standard in the main, not many variants. So basically you've got your RJ45 connector, and that's the only thing you're going to come across in the CCNA exam anyway, so that's pretty standard. With the fibre connectors, there are many different types, many different wavelengths. Now the wavelengths have to be matched, or the actual ports themselves can go up in smoke. Not good. Extremely expensive. Can be extremely expensive. But look, the most common issue is reverse cable ends. So with a fibre cable, there's a transmit fibre and a receive fibre. They need to cross over. You always need to cross over. So you've got to make sure that your transmit on one end is going to the receive on the other, and vice versa. And that's the most common thing you'll see with fibre connections, is they just haven't been matched up correctly, and then all goes to smoke and nothing happens. Okay. Now again, from the question from, I think Tim it was, we'll look at some of the transceivers a bit later on in the course, but it's not really, it's more for interest's sake rather than anything you need for the specific exam. And as you go up through the chassis, 6500s, 7600s, 8500s, Nexus, blah, 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 CRS, the requirement for ports and all sorts of things starts going absolutely crazy, man. And the number of things that you can use is completely off the planet. So they're even getting to the stage now where they're starting to flog terabit interfaces, which is, like unbelievable from where I started 20 years ago. But again, the main thing that's focused on the CCNA is whether you need straight through crossover and speed and duplex settings. Okay, LAN switching. This reference here is without doubt the finest book I've ever come across written on the art of switching. Okay, so it's a Cisco book, a CCIE professional development. Now don't let the CCIE bit put you off. It is absolutely amazing. It has got the most definitive explanation of the spanning tree protocol you'll ever come across. Spanning tree is something that you must nail for CCNA, and we'll look at that a bit later on. But if you can get hold of this book, it's freely available on the internet in PDF format. Now it's quite old. I think I bought it in the early 90s in a hardcover. I've still got it here somewhere. But you can get PDF version of it, freely available. It's well past all copyright protection, but still a brilliant, brilliant theory book. Okay, so I'd highly recommend you get that, if you can. As I said, a bit old, but underlying theories are still valid. Okay, just got another question here from Peter. Circuit switching a topic in the exam? No. No, circuit switching is not a topic on the exam. So circuit switching is more of a WAN technology, and we'll talk about that circuit switching a little bit later on in the course, but you're not going to see very much of it on the exam at all. Okay, and as I said, that LAN switching is a must for further Cisco study, in my honest opinion. Okay, okay, LAN switching. So collision domains. As I said before, a collision domain, and if I just have, I got my little diagram up. I have, excellent, look at that. Okay, so a collision domain here. If we've got a very small network here, obviously. We've got a switchy hubby thing here, and we have 4 PCs connected to it. Now, a collision domain just simply means that anywhere a collision can occur is part of the collision domain. So if this were a hub, remember, a layer 1 device which has a single collision domain, the whole device is a collision domain. So if this guy over here, highlighted there, if he transmits a packet, and at the same time this guy here transmits a packet, they'll get to the hub, they will collide with each other, they'll get broken, retransmissions will have to occur. Okay? So if that's a hub, this whole thing here is a collision domain, a single collision domain. If this is a switch, we have a separate collision domain for every port in use. Okay, 1, 2, 3, 4 collision domains. Because a switch will only send out packets at a specific port that it's addressed to. So say, for instance, this host here wants to send to this host directly above it. In its packet, in the layer 2 header, it will have its source address and it will have the destination address of this guy here. And this is where we get to the point where switches work at layer 2. So this guy sends a packet out. When the switch receives it, it says, what is your layer 2 destination address? So what's the destination MAC address? Okay. It looks at that MAC address and says, oh, okay, I've got to send it out this port to this guy here. And it sends it out that port only. Okay. So that means that it only uses those 2 ports. Oh, what am I talking about? I've gone on to broadcast domains. I'm being crazy here, sorry. So a collision domain in a switch, sorry, get back on track, Matthew. A collision domain in a switch, because there's 4 separate ports, each port is a separate collision domain, okay? So this guy, if he sends a packet out, when it gets to the switch, it's not going to care if these guys are sending packets at the same time. It's because of that layer 2 mechanism that each port is seen as a separate collision domain. Okay, so if that makes sense. I hope it does, because I was trying hard to confuse you there for a minute. Okay, now broadcast domain is anywhere where a broadcast can propagate. So if we go back to our diagram here, this thing is a switch or a hub. Okay, there is no router. Now remember we said before, routers, switches and hubs have a single broadcast domain. Routers have multiple broadcast domains. So routers stop broadcast from propagating. So say this guy here is doing a bit of broadcasting, okay, whatever it is. It could be DHCP, it could be NetBIOS, which is a big loud hailer. It could be anything. So he's sending out a broadcast packet. If he sends it to a switch or a hub, it goes in this port and it goes out every other port. There's no choice. It has to. The standard says it has to. So all these guys have to listen to it. You know, oh man, another broadcast, more packets to process, takes time off my other networking duties. Okay. So broadcast domain is anywhere where a broadcast will completely propagate. Now if we were to put if there was a router in here, so just because I haven't got the right template open, if we're going to say this is a router here and we link that into the network like so, and each of these PCs we now put on a separate network, so we say put this one on. So if we say, for instance, so this one's on 192.168.0.1, this one's on 192.168.0.1, and so on, 192.168.2.1, 192.168.3.1. Okay, now they're on, if we're using a /24 mask, which I know may not know much to now, but it will next week. If we assume that these are on separate networks, then the broadcast will not be propagated past the router. Okay, you must have a router for these hosts to communicate with each other. So without that router, if we just took that link out there, then what will happen is these guys are all on separate networks. They won't be able to talk to each other. Okay, and you'll see why next week. Okay, so this is moving on a little bit, but just for the purpose of broadcast domains, we need to have a look at it. Once that router is in place, it will stop that broadcast traffic. It'll still allow what's called unicast traffic, so direct traffic between hosts, but the broadcast domain will be separate. Okay, so that's what it means by broadcast domain, anywhere where a broadcast can propagate. Without the router, we have one broadcast domain. With the router, we have 1, 2, 3, 4. Okay, and cut down of broadcast or collisions in the main is a really good thing to have. Okay, switching types and CAM tables. All right, let's have a look. And basic configuration of VLANs and trunking. Okay, so collision domains, as I said, a collection of devices that see each other's conversations irrespective of source and destination address. Hub, one big collision domain. Switch, one collision domain per port, as we just explained. Broadcast domains, collection of devices that see all broadcasts. So these are created using your VLANs and subnets, which we just touched on, and they require that layer 3 functionality. So you must have a router to be able to separate broadcast domains and indeed to be able to talk between broadcast domains. Switch, single broadcast domain. Hub, broadcast domain for every single routed port. Okay, that can be a physical or logical port, and we'll look at that in the coming weeks. So why use them? Single port collision domains, Speed up traffic, no retransmits, less lost packets. Error must be because of something else. So in other words, it makes your troubleshooting easier. Okay? If you've got one big collision domain, man, it used to be a real nightmare to try and troubleshoot where the problem was. Okay? Single collision domain, from an electrical perspective, much easier to troubleshoot. And there will be components of troubleshooting on the exam. Broadcast domains, well, that's a no-brainer. It just cuts down broadcast traffic. Okay? So it's much easier to keep your throughput high because you haven't got that massive amount of broadcast traffic. So now switching types. 3 main ones we need to look at. Okay? So there is store and forward. So what that basically means is the switch will bring all of the packet into its buffer, into a switch buffer, into a memory buffer, check it all out, make sure that it's all okay before it sends it out. Okay, so obviously that's the best for integrity, so you know that your packet's okay. However, it's obviously the slowest as well because you've got to read in the whole packet. So the bigger the packet is, the longer it's going to take to read, the longer it is going to take to check, and then the longer it is it's going to take to transmit. Okay, great for integrity, so I don't have any broken packets, but it's as slow as hell. Okay, it's still used in some places today, but not as often as what it used to be. Okay, fragment free. Okay, what fragment free does is because of the way Ethernet works, and I won't go too much into the standard, but basically you need to understand that any collision in an Ethernet network will occur before the first 64 bytes of a packet. It will not occur after it, unless it's a late collision, which we talked about before with full duplex errors. So late collisions are a no-brainer for duplex problems. Okay, very rarely do late collisions occur because of anything else. So after the first 64 bytes are transmitted, collisions don't occur. So what fragment free does is it reads the first 64 bytes of the packet and it says, okay, is it clean? Is it okay? It is? Good. I'll just switch it up. So it only reads the first 64 bytes in the packet. So it's very consistent with how fast it sends packets out. Because it doesn't matter what size the packet is, after the first 64 bytes, it still sends it out. Okay? So you've still got the delay, you know, with bigger packets because they're longer, take longer to transmit, get out on the wire, but it's quicker for the switch to actually send things on their way. So again, it's done to avoid collisions, requires that the input speed and the output speed are matched. Okay? So if you've got lots of 100 meg connections coming in and you're going out over a 10 meg connection to your next switch or next hop, yeah, it's going to be a bit nasty. Okay? In modern fully switched networks, it's not so useful anymore because we have cut-through switching. Okay, and that is the default for many switches now. And it basically forwards the packets after the destination address is read. So it only goes into the packet as far as the destination MAC address. Okay, so you've got, which is basically right at the start, you've got a little bit of a preamble, then you've got your destination and source addresses. As soon as it gets to that source address, bango, it goes, okay, I know where that's got to go, I'll send it out. And it goes out. It's a substantial speed boost, but it is at the cost of potential errors later in the packet. Because it may, as I said, first 64 bytes, collisions occur after that. Collisions occur before that. But if you're using cut-through switching, the destination address is in the very first itty-bitty-weeny part of the packet, so the first 24 bytes. Once it gets past that, there's still that potential in those next few bytes to actually have a collision. So it is possible that you're sending out erroneous packets. Hopefully it doesn't happen, but it is possible. Okay, and adaptive switching mechanisms, which are on a lot of high-end switches now, will dynamically shift depending on the network conditions. So it may start off using cut-through. If it starts to detect a high level of retransmissions or errors, then it'll pop back to store and forward. Okay, and if we have a look here, you can see what I was just talking about there. Okay, 6 bytes. When we're talking about 20 bytes, thinking about something else. Okay, so the first 6 bytes, once it gets to that, sends it through. Fragment free, 64 bytes, store and forward all bytes. So you can see clearly from this picture here just how much the difference is in the speed of getting the packet out onto the wire. Okay, given that the actual packet is all the same size, the 15, 18 byte maximum here, huge difference in speed, which is what switching is all about. Okay, so one of the questions that may not have been asked, but it's a good one to ask anyway, is how do switches know where devices, where hosts are attached to? So if we have a look at our diagram here, not that one, Matthew, that one there, if we look at these diagrams here, how does this switch know where these different PCs are connected? Lovely question I hear asked. If I get back to my presentation, this is how they do it, okay, using a MAC address table. So every time a device is connected to a switch, as soon as it starts sending traffic, there's two components it must have. It must have a destination address and it must have a destination address and a source address, okay, and these are the MAC addresses on the actual hosts themselves. When any packet goes into a switch, the switch will read, okay, the destination and the source address, and it keeps a note of which direction those those source addresses come from. Okay, so say for instance here you can see this top entry here, the MAC address 000B CDE776E0 is known through port gigabit 0/1. Okay, so that means that the switch has seen a packet come into that port with the source address of that MAC address. Okay. So it says, okay, I know that source is on that port, so I'm going to build an entry in my table which says that MAC address is on that source. And it keeps it there. As long as packets from that host keep coming through, it keeps it there. And what that then allows it to do is when a packet comes in that says, I want to go to the destination of 00B CDE776E0, it automatically knows, oh, okay, it's got to go at gig port 1. Bang, off it goes. Away it goes. Same for all these entries here. Now, an interesting thing you should be able to note from here is of these 13 MAC addresses, we've got 1, 2, 3, 4, 5, 6. 6 ports have 6 MAC addresses are at the same port. Okay, have a think about what that could mean. Okay, so if someone wants to answer that, that would be fantastic. So just have a think about what that means, and also there's a couple coming from 21 as well. Have a think about what that could mean in the context of what we talked about. Okay, so table and switch memory records layer 2 MAC addresses of every connected host and port. That's what your CAM or MAC table is. CAM is content addressable memory. MAC is media access control table. Okay, so they're basically the same thing. You'll see some text will talk about CAM table, some text will talk about MAC table. They're the same thing. Exactly the same. Okay, switch populates CAM table by examination of source and destination packets. Already talked about. It's limited by the switch memory. Okay, so how much memory your switch has determines how much it can fit in its memory, and obviously how many MAC addresses it can fit. You can limit it. So if you say you've got 24 ports and you say I only want 24 MAC addresses, that's fine, you can do that. You may miss out on some communication, but you can do that. And it ages out the CAM or MAC entries over time if devices are not heard from. So you can do it manually, you can clear out the CAM table manually, or over time, if packets from those hosts don't come through, then you will be, those entries will actually time out. Okay, run a bit of time here, sorry. I'll keep going. Okay, basic switch configuration. Let's just do a bit of a quick lab and have a look at it. Okay, so if we see this window here, oops, actually I won't totally maximize that because otherwise those black areas of death, we'll get into that. Okay, so this switch has already been configured. This is actually a switch I have here in my lab. So if I do a show run, okay, so now, just a quick primer. This is obviously a Cisco IOS. This is a 2950 switch, so it's a bit old now. 2950, 2924, no, 2950, there it is behind me. Okay, so it's this particular, where we are now at this prompt here is called enable mode. Okay, so if I go disable, you'll see that the prompt changes. Okay, so when I'm in that mode there, that's just basic access mode. In the Cisco environment, you can use a question mark. And when you use a question mark, it tells you all of the different commands that you can use at that valid mode. Now you can see here I'm just in everyday administrator mode, nothing special. I can't see a whole lot. Okay. If I go into enable mode, it'll ask me for my password. I'll type that in. The prompt now changes to the old pound sign. Okay, that means that you're in enable mode. And it's very important that you understand these different modes because you will see them on the Cisco exam. Okay, you will be required to change in and out of these on the Cisco exam. So now we're in enable mode, and if I hit the question mark again, I've got bucket loads more commands. Okay, so that's just it. We go, and again we'll go through this more as we go through. At the moment, I want to have a look at the show. I want to have a look at the running config. Now, one of the things about typing in Cisco commands is you'll see me do that. Okay, I abbreviate everything because I'm old school. I've been doing it for years and understand what the command terminology is. In the Cisco exams, you may have to put in the full configuration, the full configuration command. So it's probably best is when you work with the labs, when you work with this equipment, yeah, just do that. Okay, use the full command, get into the habit of it, and then later on you can be like me and just go show run. Okay, so let's have a look at the run and talk about the basic configuration. So basically the configuration on this switch, the basic configuration that Cisco expect you to be able to do for the exam are this. Host name, being able to set a host name, okay, and this is a configuration file from this switch, and this is literally the commands you need to input to change the host name. Okay, so if I was just to control C that for a minute, and then I was going to go into configuration mode, okay, so configure, it'll ask me what do you want to configure. I want to configure by terminal, hit enter, and it puts me into config mode. You can see the config word there now. That now means I'm in configuration mode. So if I want to change the host name, I would type in the keyword host name, question mark, okay, now it says this system's network name. So you've got to put in a word which describes the system's network name. So I'm going to change it to MOOC test. Bang. Now you'll see the name has changed. Okay, so that's one of the things that you need to do to be able to do in basic switch configuration, change the name. Okay. The other thing you need to do, if we go back to the show run, and there's lots and lots of rubbish here, so don't worry about this, we'll cover it all as we go along. The other thing you need to be able to do is to set an IP address. Okay. Now because I'm using VLANs on this, and we'll talk about VLANs now because that's also part of today's course, so I'll talk about those briefly in a minute, and we'll cover them more in the coming weeks. You need to be able to set an IP address as well. Okay. And again, if we follow through, we go into configure mode, okay, into terminal, we go into interface, sorry, I'll behave myself, do the full command okay. Well, fat fingers, interface, VLAN, now I'm going to use VLAN 2 here, okay, no I'm not, I'll cut myself off if I do that, so I'm going to go interface VLAN 1, we can set an IP address. Now it may give me an error because I've already got an IP address on VLAN 2, depends on the iOS, so don't just ignore that. So IP address 192.168.1.3, let's say, and we put our subnet mask in, and we hit enter. Okay. And now if we do I'll just do it from here because I can, we do show run. That's one of the great intricacies of the, you'll see now that there is an IP address on the VLAN 1 interface. Now it's shut down, so it's not going to do anything, but the IP address is there now. Okay, so you need to be able to set a host name, an IP address, and a default gateway. Now the default gateway is important because these interfaces we're talking about on the switch here that we're configuring at the moment, the VLAN 1 interface, is got nothing to do with routing, because remember switches only work at layer 2, so it's nothing to do with routing. It is only for management access to the switch. That's all it's for, and for things like SNMP monitoring, which again is management, telnet, SSH, all that sort of stuff. Okay. So effectively I could remove all the IP addresses from this switch. I would lose access to it, so we couldn't do any more demo on it, but at the same time we would not lose any access through the switch. So my internet connection still work, my PC would keep working, this webinar would keep working, it wouldn't matter. The VLANs on a switch in this context are only used for switch management. So as you can see, being my own home internal network, I've got my VLAN, I'm using VLAN 2 as my management address for my switch, and that's the IP address I've just put on there. So I don't need to really do anything else. And that's pretty much, really, in a nutshell, the main things that you're going to have to do. The only other thing you may be asked to do is to set speed and duplex. on a particular port. So if I choose a port that's not in use, because if I choose a port that is in use, I'll upset someone. So let's say, and to do that, I'll just confirm as show IP int brief. So what show IP int brief does, you don't need to know this command, it's just showing me what ports are up and down. So say if I use port 17, so I go back into, wow, that's crazy typing. Go back into configure terminal. I go into interface mode, fast Ethernet 0/17, and I'm now in that interface mode. You can see how the prompts change. Now it's configure interface mode. I can now go speed, hit the question mark, and it'll tell me what do you want me to do. So I can go 10 meg, 100 meg, or auto, in which case it will decide itself. So I'm going to say speed 100. Then I'm going to look at the duplex setting. Okay, duplex, what can I do? I can do auto, so I want to negotiate full or half. Now it is quite valid to have the speed set and the duplex on auto. You can do that if you want to. I wouldn't recommend it. I'd say if you're going to set one, set the other, but you don't have to. But I'm going to set it to full, and then I'm going to exit out of interface mode, takes me back to config mode, exit again, and I'm back to normal mode. So if I now go have a look at show run, so it just shows me the running config of interface, fast Ethernet 17. You can see now speed 100, duplex 4. Okay, and they are basically the only things you're going to need for basic configuration. Okay, so host name, IP address, default gateway, speed and duplex settings. The other thing you may have to do is VLANs. Okay, so just quickly, a VLAN will create a broadcast domain. Okay, so remember, broadcast domains work at layer 3, and you heard me say before VLANs work at layer 2. So what's all that about? Well, VLANs, although they work at layer 2, will separate broadcast domains. There's two components to VLAN. There's a layer 2 component, and if we switch back to here, if I do show VLAN, you'll see these are my VLANs that I have on my switch. I have one, which is a default VLAN. That's always there. You can't delete it, can't change it. VLAN 2 I've called internal, so that's one I've created myself. I've created a DMZ VLAN for testing, and I've created a VLAN 4 for external access. Okay, so they are layer 2 VLANs though, only layer 2, not layer 3, layer 2. So all that basically does is takes my, you're able to then allocate the ports, as we can see here, to a particular VLAN, and that separates those ports into a broadcast domain. So if we look at it here, I've got two broadcast domains. I've got a VLAN 2 internal, which has all these ports as members of it, and I have one port all on its own in this broadcast domain here. Okay, so two separate broadcast domains. So automatically that should tell you I need a router to talk between them. Okay, router to talk between them, or some layer 3 device. Now in my case I haven't got a router, I've actually got a NetScreen firewall, but it's doing the same thing. It's routing. Okay, now sorry, I've just missed a couple of questions here, so I'll answer some of these questions here. Very, very sorry, I'm getting a bit carried away myself. First one from Tim. Again, Tim, you're going gangbusters, mate. Can you use help in the exam? Yes, you can. You can use speed, question mark. Yes, you can. You can do that. The content, missed that one. Okay, for CCNA, switches cannot route between VLANs, even though some in real life can. Layer 3 switches, again from Tim, thank you Tim. Layer 3 switches can route between VLANs, absolutely, but you do need some sort of layer 3 device to route between VLANs. Okay, question from Peter about, does Cisco still teach that you can't use the top and bottom subnets? We're going to go through that next week, Peter. But yes, don't use the first and last addresses in a subnet. And we'll talk about more about that next week when we do IP addressing. If you have a larger subnet, so a supernet, you can use the addresses in the middle that may fall across what would normally be a classful boundary. But we'll talk about that more next week. But yes, they still teach that. And lastly from Boris, does an IP address have to be set for every port or just a switch? No, just for the switch, Boris, because it's only for management of the switch itself, so it's got nothing to do with actual traffic going through the switch. it's only for management of the switch, given that these ones are only layer 2 switches. Okay, again, sorry, VLANs, back on the VLANs, you require layer 3 device to transit between VLANs. So if you haven't got a layer 3 device like a firewall or router, not going to work. Okay, impact on traffic, subnet size, security and function, etc., etc. So in other words, that's why you would use VLANs. Okay, if you separate, if you've got more VLANs, you've got more, you have more broadcast domains. So it cuts down on your broadcast traffic. VLANs help you to separate your subnets out, and we'll see how that works with IP addressing next week. But basically it makes the number of IP addresses you have in a single network smaller. For security, so you can create a VLAN, then put an access list or a quality of service policy on it or something to, prevent either certain hosts from overrunning the bandwidth requirements or getting access across that VLAN, and to break down into functional groups. So for instance, you've got an R&D group, you've got an education group, you've got payroll, you've got management, you've got voice, you've got video, you've got wireless, whatever. Break them down into separate VLANs and keep specific traffic types within its own specific area. Okay, so that's why you'd use VLANs. Okay, let's have a look at a lab. Okay, that's the end of our slideshow, but I just want to quickly go through a lab. Now this time I'm going to use the actual ICND lab. So this will be something that you will see. Hopefully I'm going to use the ICND lab. I am going to use the ICND lab. Okay, so this is what you'll actually get when you register and pay for your one of these learning labs here that we went through earlier in the day. This is basically what you'll get. Okay, Cisco Learning Labs ICND version 2 for classroom students, so you're going to get this one here on our labs. Okay, now as you can see, wow, look at this. These are the labs that you will get in this particular course, okay, for this particular, so this is the ICND version 1. These are the labs that you can use. So performing switch startup and initial configuration. Okay, we've covered a bit of that today. So if you get these labs, I'd recommend you do that lab before next week. Operating and configuring a Cisco iOS device. Again, that's the basic host name, IP address, blah, blah, blah. Have a look at that. Enhancing the security of the initial switch. We're going to cover that a bit later on. Okay, so if we look through the number of labs we've got here, you can see there's a bucket load of stuff that will all be very, very useful for creating your knowledge, for building up your knowledge ready for the exam. Okay, they all sort of lead you through hand by hand, and there's a number of steps to each one, and they help you out along the way. So if we just have a look at this one, for instance, and we can add a bit of our VLAN creation in here. Okay, so if we begin our lab, okay, I'll just close a few of these windows off. These guys are just messing with my chi. Okay, look at here. Okay, so it gives you a number, as I said, gives you a number of steps here. Okay, so it gives you some information on what you have to do. Connect or assign workgroup switch, and then it will actually show you the steps. Okay, so you can cheat if you like. Well, not cheat, I mean just get a bit of a leg up, or you can hide your steps and just have a go at yourself. Okay, so verify switches unconfigured and reload, system configuration dialog to produce an initial configuration, add VLAN 1 and default gateway to initial configuration. Okay, so if we start it up, would you like to enter the initial configuration? No, well, we're not going to do that. So this is actually connected to the real Cisco lab, so this will give you an idea. So the one before was actually my switch here. This one's actually on the Cisco lab, so this will give you an idea of how closely aligned it is. Okay, so obviously there's a little bit more latency there. And if we go into enable mode, as I said before, okay, now if we have a look at show VLAN is our main command. Okay, we've got one VLAN on there. There's Mr. Default VLAN. Okay, so the only things we need to do in terms of, so we've spoken a bit about the theory of VLANs, and we just have to have a quick look at how we actually create a VLAN. Now remembering that this is configuring the layer 2 component of the VLAN, not the layer 3 component of the VLAN, which is required for routing. So you need an IP address or a router device, whether it's a firewall or a router, to move packets between VLANs. But in order to do that, you need to create the VLANs in the first place. So the way we do that, configure terminal, we're now in terminal mode, we simply type in, let's have a look at the command. So if we type in V and then the question mark, what it does is it'll give you all the commands you can use that start with V. Okay, so virtual profile, virtual template, VLAN, that's what we want, VRF, oh God, don't look at those, service provider stuff, and BTP. So if we say VLAN and we do our question mark, and the reason I'm showing you this is I want you to use the question mark as often as you can, because the more you use it, the more you'll start to build up your knowledge of what's in the Cisco IOS and what you have to do. Okay, so VLAN. So Word, ISL VLAN ID is 1-4094. What the heck does that mean? Okay, that means that that's how we create our VLAN. So VLAN, and then we put in the actual VLAN number we want to create. So in this case, we've got a VLAN 1, which is default, as are these VLANs here. And crazy that they still have these, because these are really old legacy stuff. FDDI, token ring, that's fiber distributed data interface, token ring, fiber distributed network, token ring network. Old school stuff, no idea why they're still there, but they are. Okay, VLAN 1, as I said, is the default Ethernet VLAN. We're going to create VLAN 2. And we just do that by VLAN 2, and we hit enter. VLAN's now configured. Now you'll notice that the prompt now changes to config VLAN. So now in here, there's a number of context-sensitive commands for this context that we can then configure our VLAN with. So really the only thing you need to do, that's as much as you're going to need to do for the exam, is just create VLAN 2. The only other thing you may have to do is name it. So you would type in name, question mark, and then use it a test name. So we'll just be boring and call it VLAN 2. Okay, and we will exit out of our configuration mode. Notice it says applying VLAN changes, might take a few minutes. So what will happen is when you make that change, it's not until you exit out that it actually creates a VLAN. Now if we go show VLAN, bingo, there she is. Now, just to demonstrate what I was just saying, so you don't think I'm a big fat fibber, if I go into configure terminal and I go VLAN 3 and I type in name VLAN 3, and then from here I do a funky command called do show VLAN. Now what do allows you to do is run any command from any location. So for instance, if I do, I hope this doesn't make a lot out of me with this iOS, if I go show VLAN, it'll go, no, sorry, I don't understand what you're saying about, because it's not, I'm not in the correct mode to be able to run that command. But if I go do show VLAN, it will automatically say, okay, fine. Now notice I've just created VLAN 3, but it's not there. Okay, and it's not there because I haven't done exit. So make sure when you're doing your exam, if it asks you to create a VLAN, don't go VLAN 3, name, VLAN 3, and then go, okay, I'm done, and close a window, because it'll go wrong. You must exit, and then if I do it again, do show VLAN, okay, it's there. Okay, so you must make sure you do that. Must make sure you do that. The only other thing you may have to do is to add a VLAN, a port to a VLAN. So notice we've got our ports over here, we've got our VLANs over here. No, nothing in VLAN 2 or 3 because I've just created them. So let's put Ethernet 00 into VLAN 2, and we do that by using switch port access, so it means it's an access VLAN, so it's not a trunk port, which we'll cover in later classes. It is an access port, VLAN 2, and I see there's a couple of questions coming through. I'll get to them in a sec, so bear with me please. And if we put in Ethernet 1 and we go switch port access VLAN 3, and we don't need to do any application here, so if we go do show VLAN, you can now see that I've got Ethernet 1, Ethernet 0 in VLAN 2, Ethernet 1 in VLAN 3. Okay? And look, in a nutshell, that's all the configuration you need to do for the exam. Okay? Now the exam is very much hands-on. There'll be a lot of questions which will require you to get into equipment like this and do, different pieces of configuration. Later on in the course, just before the last week, I'll talk about the sort of questions you look at. So there'll be multiple choice, drag and drop questions, there'll be simulation questions, there'll be scenario questions. We'll talk about that in more detail as we get closer to the time, but for the moment we need to look at the theory. So in terms of our actual MOOC today. That's the end of the technical content, but if you just stay with me for a few seconds, I'll answer these questions for everyone. So one question from Wayne, does the new iOS complete a write memory automatically on exit now? No, it doesn't. It's that writing there was just for the actual purposes of the VLAN, so it doesn't actually write your configuration back to memory. So yeah, obviously you've had a bit of experience because you've got write memory instead of copy run start, which is a typical way now. So old school, love it. No, you still have to do your write memory, Wayne. That's the link. So just to show you the difference, if I have a look at a flash on my switch, not with that command I won't, if I have a look at the flash on my switch, you'll see there's this VLAN.dat file. That's actually a text file on the flash. When you exit from the VLAN configuration mode, that's what it's writing to. And that's just so on a reboot, that VLAN data is already there. It's not actually stored in the configuration. It's actually stored in that VLAN.dat file. Okay, so that's one. Okay, so again, yeah, question about you joined late. Will you be able to go to the lesson later? Absolutely. Within 24 hours, it will be up on the IT Masters website for you to be able to access through Moodle. Steve Collis, is using Packet Tracer good enough for this? Yes. I'll give that a qualified yes. It is. Not everyone's going to have access to Packet Tracer, but there are some limitations to what you can do in Packet Tracer. Not too bad for CCNA level, but yeah, it's not as good as these labs, but it will suffice for most of it. So you could use Packet Tracer if you're in an environment where you had access to other stuff. I don't think that would be a problem. Okay, I don't think we've got any other questions that we haven't answered. I'm quite happy to hang around for another 5 minutes. If you've got questions, that's quite all right. Otherwise, thanks very much for attending. Next week we'll be going through some IP addressing, so IPv4 mainly. IPv6 you don't need to know too much about, but we'll talk about the address classes and what they're used for. So until then, you're quite right to pop off, and in the next 24 hours this webinar will be uploaded onto the IT Masters Moodle site, and you'll be able to access it there. The resources are already there, so I'd fully encourage you to go and have a look at those. If you would like to also read ahead for the IP addressing for next week, particularly if you haven't had much practice with IP addressing, it can be pretty complex. So if you want to have a look at that, that would be fantastic. I'll see you all same time next week. Thanks very much.